Hello everybody. What I'd like to do today is to solve all the really big problems we have in physics with one single simple solution. Now in science we have to peer review everything that we do. So we've had the answer for about 3 years, but we needed to work with the universities here in Taiwan to make sure we've got everything finished before we present it in public. So last Saturday, that's where we were. We presented in public a unifying theory that puts together the two very distinct parts of physics, quantum mechanics and relativity. And when you can do that, it leads you on to a theory that explains everything. Chemistry, biology, physics, economics, anything you can think of, all fits together with a single underlying principle on which the whole universe works. So let's show you that principle and see it working again and again as the universe brings itself into existence. Now our two different parts of physics, quantum mechanics, how atoms behave, and relativity, how planets and stars behave, are completely different. Electrons jump orbits without passing through any space in between, whereas planets move smoothly from one orbit to another. Two completely different sets of rules. And as we believe, there should be one common set of rules which explains everything. Well, that's what we're looking for, a single set of rules. Now, as we go through the history of human beings trying to describe reality using a collection of mathematics and science, we start to notice a pattern, a periodic repeating pattern. We'll start with Pythagoras. And he finds that a circle doesn't have a circumference that you can measure. It's got a number which becomes infinitesimal. It goes on forever. But I've got a radius that I can measure. I've got the finite and the infinite. It separates into two. And then he finds with the square root of 2, we have numbers which are also infinitesimal, that just go on forever. The rationals and the irrationals. And then when we get to Newton, he discovers that although his mathematics works beautifully for two bodies in space, as soon as you try and apply it to 3 bodies in space, it doesn't work at all. The French mathematician Poincaré writes a mathematical proof that shows there are no mathematical analytical solutions to 3 bodies in space. None. That's a big problem. So this is where mathematics, science separate out. Poincaré with his mathematics and the physics, which only works for 2 bodies. But then it gets worse. We end up with the rules of quantum mechanics, which are completely separate from Einstein's rules of relativity. So now we're in a big problem. We can't describe chemistry, genetics, using physics. So why don't the building blocks lead to the building? Well, this is a human problem. We think that small should always just lead to the big, but we find it doesn't. So where do we find an answer? Well, the Scottish natural philosopher James Clerk Maxwell shows mathematically that electricity and magnetism are the same thing. Faraday shows it physically. So we've got physics and mathematics. And there's 2 parts of the same thing. Now that's common through all of quantum mechanics. Everything must just be 2 parts of the same thing. It's not just quantum mechanics. Think of a lever. I just exchange force for distance. So this problem that we've got, if I just consider that everything has to be 2 parts of the same thing, I get a different answer. let's have a look at physics. It's in two parts. But if I think of the electron, it's got two answers. One, the electron has a charge, and it's not -1. That's its numerical charge. It has a physical charge of 1.6 times 10 to the -19 of a coulomb. I've got two answers. Well, isn't this what Einstein also showed? That energy and matter, E equals mc squared, are two parts of the same thing. But there's a very, very different value on how much energy we've got. Mathematically, we've got an equal sign, but the value of the energy is vastly different. C squared, the speed of light squared. I've got huge amounts of energy from a tiny bit of matter. Well, what is matter? Well, matter turns out to just be a relationship. Mass, a relationship with the Higgs field. It's a relationship. Well, that's what this is. Niels Bohr calls it complementarity. Nothing exists that isn't a relationship. So if I change my mind about just wanting one kind of physics and say that reality can only be described as a relationship, a complementary pair of physics and mathematics, they're the same thing, two parts of the same thing. Doesn't matter what you look at in physics, there's also a mathematical value as well. So if I look at the smallest units, the Planck units, they come in mathematical values of 1 and 2 pi, or 4.135 times 10 to the -15 of an electron volt. Everything comes in these two answers. And this really does solve our problems. Because if I've got two parts to the same puzzle, I can now use any part of mathematics I want to describe reality. So it's not just a single part of physics, it's a complementary pair. Now it takes a little while for your mind to change over. Just because you see logic doesn't mean to say you change your mind. But if you go through atomic theory, all over atomic theory, you find it described by mathematical functions that were written hundreds of years ago. Atomic orbitals, here, spherical harmonics, written by Simon Pierre Laplace in 1887. You can't just do that, say, oh, we'll just pinch this mathematics. I just use it for atomic theory without an explanation. So here is the explanation. Here's another one. A new derivation of pi links quantum physics and pure mathematics. It's all over atomic physics. The zeta function describes the Bose-Einstein condensate. The Mobius function describes the relationship between the particles which carry forces, the bosons, and the particles which are moved by the bosons, the fermions. So here, if I use this complementary pair, I start to get a sensible universe, one in which atomic physics can change over into genetics. I can't explain this without very, very complex mathematics, which was first understood by an English mathematician called Littlewood, who finds out that the genetics knows more about mathematics than he does, because once he's applied the mathematics, he finds that genetics has a lot more mathematics to put back into mathematics and give him answers. It's pure mathematics. So physics, just too simple. So if I think of the solar system, it has deterministic parts and non-deterministic parts, predictable parts and unpredictable parts. How can I match those two? I say it's a combination of both. The physics, nice, simple physics that we get from Newton. That just describes how the solar system holds itself together and why it moves. But how it moves, it need all the gears of harmonic resonance and perturbation theory to make the gears of my clock. So there's your physics, and there's the mathematics that changes the solar system into a predictable and unpredictable system at the same time. Physics, by definition, is deterministic, either at the atomic level, where it goes from a deterministic wave into the probabilities that we find when it's a particle. So here's complementarity again, wave, particle. And that must show up in mathematics. And it does. And that mathematics was written hundreds of years ago by Euler. In his famous equation, e to the I pi equals -1, and e to the I pi equals +1, equals 0. So I've got -1, +1 and 0 on one side, the particle, and e to the I pi on the other side. This is how we get sine waves out of circles. So let's just put this into practice. So my energy of physics will take the electron or the proton, 1.6 times 10 to the -19 of a coulomb, which can either be minus for the electron or plus for the proton. But we've got -1, +1 in mathematics. We've also got the mass, which is completely different. I've got a lot more mass in the proton than I have in the electron. But let's now just put particles and numbers together. And what you'll see is you get the same thing in mathematics and numbers as you do in physics. Now, you're all quite used to looking at magnets, and the way that the brain works is once you get used to something, not a problem. But there must be some mathematics here, must be, that's causing this to happen. Now in physics we say these are virtual particles. Well, isn't that a get out of jail free card? Mathematically it behaves just the same as a real particle, but as you can see there's nothing there. But that happens to mathematics, imaginary numbers. You can't do mathematics without it. So we'll say here there must be particles and numbers for everything, and they must match up. So in mathematics, we put numbers on the Argand diagram, the real numbers, positive and negative. My particles, positive and negative. Well, now I'm going to take electric, magnetic, virtual particles, strong particles, and say they can be my imaginary numbers, but they're positive. They're a much bigger energy level than the negative particles, which make space itself. So it's to do with energy levels. So I can call now all of this positive and minus. That just means they're vectors. But then all of this becomes positive energy, and this becomes negative energy. So now I've got numbers and particles for space. Real numbers make real particles, the electron, the quark, the neutrino, from which I'm going to build everything. Negative numbers make radiation particles, photons. Virtual particles, the electric, magnetic, virtual particles of space. And the particles that make space itself, the lowest energy level, the Planck units. Now you can see if I just put them together, I get interaction, both at an individual level and a collective level. So if I put my real particles and space together, I get a relationship that we call at the individual level mass of the particle, or at the collective level gravity, the field between the strongest, the biggest energy level and the smallest energy level. If I put virtual particles of electromagnetic virtuality together with the real particles, magnets, I get electrical fields, magnetic fields. EM fields, strong virtual fields, nothing there, but just as real. And if I put these particles, photons, and these particles together, I get electric magnetic fields which change into waves, polarized waves. And if I put light particles and space particles together, I get a reaction that light itself, energy, is curved by space. And if I have enough matter curving space, it will change space into a sphere, just the same as space changes matter into the spheres we call planets and stars. Matter changes space into the spheres we call black holes. And light will just go round the sphere. So here I have an answer. So let's put quantum mechanics and relativity back together using complementarity. They must be the inverse of each other. There are two kinds of complementarity. One, things act together because they are the inverse of each other, positive and negative. Things act against each other because they are the opposite of each other. The very weak energy levels of space, the very strong energy levels of matter, cause matter, the particles, and gravity, the relationship which we call Higgs field. So how can I show that quantum mechanics and relativity are the inverse of each other? Easy. What you know about one, you don't know about the other. At the quantum level, quantities, I always know the quantities. They're all the same, they're all exact. But I don't know the position and the momentum. At the gravitational level, I know the position and momentum, but I don't know the quantity. That's it. The biggest problem in physics solved. Up here, I've got my opposite. Physics is predictable. But I need some mathematics here that describes the unpredictable. The unpredictable parts of chaos and complexity theory. Purely mathematical. It's all in books like this. There's no physics in this book at all. But I need this to explain self-organization anywhere in the universe. Self-organization is unpredictable because I don't know what it's going to make. You think of the animal kingdom. Unpredictable, but self-organizing. Same with the solar system. And chaotic behavior. We still say they're two separate disciplines, but complementarity means that one is the inverse of the other. Chaos or self-organizing. Is it starting to make sense? So here's my two parts of physics matched up with mathematics, and I get a description which allows me to put chemistry, physics, biology back together. The two parts of physics now can stay separate in their own domains, and added to mathematics, I get a logical description of the universe. So let's put relativity back together. Now we've got a good description of energy and matter. That's all sorted out. But space and time, and we have to put these back together. That's not sorted out. So to quote Roger Penrose, one of England's best thinkers, the major revolution, which I do think we need, would involve a complete rethink of not only quantum mechanics, but how we look at space and time. So there will be a revolution waiting in the wings. And when that revolution has come, maybe we can think about the issue of what thought is. And my view is conscious thinking does depend on the missing part of physics. Well, if we say the missing part of physics is just mathematics, it solves my problem. I've got the physical parts of my brain, but I don't think with them. I think with the non-physical parts of mathematics complexity, where just the parts or the thoughts interact with the language which is producing the thoughts, two parts of the same thing. So let's put space and time back together with energy, matter. First, I've got to separate space into two parts. The strong energy, just the same as matter, is more energy, the radiation, and the weak energy level, positive and negative. So that's separated into positive and negative. What about time? Well, time is events, change. The whole of mathematics is described as the relationship between quantities, the qualities, space, relationships, and change. Time is change. Now, time can either be assembling something in the universe, putting things together, or like a supernova, breaking things into parts, getting them ready to reassemble. Now, physics, we've got entropy. We only have entropy, which goes from order into disorder. So, terribly, we use the word negative entropy for the formation of stars and when things are being put back together. But negative entropy must be something else. But there's a problem with the second law of thermodynamics, which only goes from order into disorder. It doesn't disallow negative entropy, but I'm not allowed to use it, otherwise I end up in contradiction. So I've got to have something here which allows for the assembly of everything in the universe. And now I'm not saying it's only physics, it's a combination of physics and mathematics. I can state that this is evolution, which can take place mathematically. So the formation of stars and elements. You see how easy it is. I don't just say gravity forms a star. It's the star making the elements, and it's the energy released from the from the elements which is holding that star up. It's a complementary pair. The biggest things in the universe making the smallest things, and the smallest things making the biggest things. The strongest force, strong nuclear force, acting against the weakest force, gravity. You see how easy it is. So my mathematics, which is missing from here, there's no mathematical patterns, turns into the geometry and the numbers which are making each other. So let's just put that into my little pattern here, my inverse pair and my opposite pair, and let's put the forces into the same pattern and see how easy my description of reality becomes. If I go over here, my different kinds of numbers, inverses and opposites, forces, I must put them now as complementary pairs related to numbers. If I've got space, I've got my imaginary numbers, which are positive and negative. Negative for the fabric of space itself, positive for the electromagnetic particles I need to make the fields. Electromagnetic numbers, inverse pairs. Now I have to put the strong and weak nuclear forces together as opposite partners. This is going to make the nuclei of atoms, but I can't make it by itself. The nuclei of atoms uses these two as complementary partners. I've got neutrons and protons, two different kinds of particles. One, the proton, which has electromagnetic charge, but they both have strong nuclear force. And this force and these forces act against each other in the nucleus. The strong force pulling them together, the electromagnetic force pushing them apart, and this stops nuclei becoming too big. They There becomes a point where the electromagnetic force, which is conserved over a distance, can repel the protons on the side of atoms, but the strong nuclear force can't pull over a distance. So this wins in the end, even though it's not stronger, and it splits the atom and breaks it down into smaller parts. Otherwise, the sun would just make a giant nuclei. So these two complementary partners, made of two complementary partners, make elements. I'm just going to say the nuclei, but if I put matter and space together, the elements, as I make them, in a complementary relationship with these numbers, give me stars. And if I pull electromagnetic particles together, they start to repel, and I get planets. Now there must be two answers for everything. So elements, when they're small, we're just going to say it numerical, but when they're big, when they get to the Planck mass, we'll say they become objects. They start to behave relative to gravity as well as the atomic forces. Two answers. So gravity must have an opposing partner, something that stops the Earth from going into the sun. And it does, and that splits into complementary pair as well. Gravity, the opposing force of gravity is acceleration. And that comes from the two geometries of non-Euclidean geometry, of geometries of curves, and the conservation of linear momentum. When you throw something in space, it wants to go straight on. The conservation of angular momentum. As I go around, my momentum is conserved, and I spin faster and faster and faster until the gravity pulling me into the sun is balanced by the rotation that I've got as I spin in my orbit. I end up stopping just in one place. So there's gravity with its partner, two laws of conservation, angular momentum and linear momentum. My imaginary numbers making stars, planets, elements and objects. How easy is that? So that's the static the physics underneath the complexities of at the atomic level, when I move over into the evolution of molecules, chemical evolution, and then life and viruses. Now, mathematics is used to describe molecules, not electromagnetic forces. This is group mathematics written by Everest Galois in the 1800s. Now that just becomes ever more complex until I get on to viruses. Just take a look at some viruses. They're very, very complex geometric structures. Geometry is just a relationship between numbers and shapes, three parts of the triangle. When I get to the sphere, then I've just got one thing that I can say about it. It's beautiful symmetry. Now I see that in these numbers here. My symmetrical numbers against my non-symmetrical numbers, the odd and even. And what I notice is it's all based on the relationship between 2 and 3, the first two prime numbers. So this is the little algorithm that builds everything in the universe, and it's based on the first two prime numbers, symmetry and asymmetry, another complementary pair. And there's a ratio between the right amount of symmetry and asymmetry we call the golden ratio, which starts off static, but that moves on as we build things in complexity theory to building two more ratios, which tell us how complex systems work. Complex systems we call genetics at the atomic level, or the physical parts of life when it becomes bigger than a cell. So a cell just becomes another unit. A star is just another unit that can act against other units, and I get more and more complexity, the system of the universe. So let's look at this little pattern working straight away in the formation of neutrons and protons and atoms. I've got two inverses, two up quarks, which by quantum rules cannot be identical. They must spin in opposite directions. Doesn't matter, you can use lots and lots of different aspects of them. Match to one down quark, the opposite, and I get the proton. Two down quarks up quantum, I get the neutron. Neutrons and protons, and the electron, I get the atom. So this little algorithm goes all the way through science, mathematics. Here it is. I'm going to come to the camera and just show it to you. But what I've done, I've rearranged the standard model here, all into the same pattern. But you can see it here, making all the parts of the elements, mathematics, and we get down here even to dimensions, and then Noether's principle, and then the whole thing, nonlinear mathematics, quantum mechanics, and relativity. Now that is very, very strong evidence, a periodic, repeating pattern that assembles everything. And it also solves my problem of what left and right are. Now in physics we've only got 3 dimensions, but in mathematics you can have as many as you want. Complex analysis, a dimension is simply another variable. But here I've got 6. So that's what left and right, front, back, and head and tail are. I've got mathematical dimensions. So I've got 3 in physics, and I've got 6D, which allows me to explain evolution and entropy, and these two have to be homogeneous to satisfy Noether's principle. And they are. The mathematics that underpins change is the exponential function. E to the x, e to the x. So I've now got time, which is positive when it assembles things, negative when it's breaking things, when a star dies, or you die, you become disassembled back into the elements that make soil. A little seed falls in the soil, and time goes back this way. The change becomes positive. So now I've got time separated into complementary partners, space into complementary partners, and matter into complementary partners. And they all fit nicely together in my 6-dimensional mathematical diagram. So that's my parts of relativity, just relationships. In between each one, there's all the relationships. I've got the evolution here based on e to the x, which will be both at the individual level and the collective. So that's the difference between differentiation and integration. One, I'm looking at the rates of change of the collective, and the other at the individual level. And again, it's the inverse. So my wave-particle duality, which shows up in mathematics, e to the I pi equals -1, e to the I pi plus 1 equals 0. There's the particles, there's the wave. So now my complementary wave particle, it works. Now it can all be shown on this diagram here. Now this is what is already being used in schools in Taiwan. We've changed the curriculum so that young children start learning this at the beginning. They start where it all starts. They can all understand this, no problem. It's very, very easy. Once it's all sorted out, it's a simple answer. So this is what we use. We also go into industry in Taiwan, and we show them that in pure mathematics, there will be the answers that you need. It doesn't matter what you're working in. Because we've now got chemistry and biology. So a few months ago we went into a company that makes vaccines, showed them that viruses are just mathematical structures, and pure mathematics has the answers which we'll all need over here. So in universities we have to start working together. So we've been causing our own problems. Now this also, we'll put this into a nice little diagram like this, which shows the two different parts of physics, the simplicities matched with mathematics, and the mathematics which we observe all over nature, the Fibonacci sequence in plants, the golden ratio in animals and plants. So this is what we use to show people how reality fits together. So if you'd like copies of this, it's all free, there's no problem. We've now got a solution that physics and mathematics can use to change into chemistry and biology. So human beings work as a complex system, the individual behaviour we can't predict, but as collectives. We are predictable. And the only thing that you can predict on here are the ratios of the bifurcation points and the self-similarity of how those bifurcations open up. So that's very, very different from physics, where at the classical level I've got predictable individual behaviour. At the atomic level I've got both the wave function, which is completely deterministic, and then as it goes into particles it becomes probabilistic. So really my wave particle, and there's been lots and lots of nonsense about does the wave function really collapse? I need other universes to explain it. No, you don't need other universes. This is very, very simple. It just uses what we have on the table. It's been sitting right in front of us. And there's been no progress in how we solve this problem for 100 years, ever since Einstein got relativity, and then we had quantum mechanics. And we're trying to squash it all into one kind of physics, and you can't do it. So this is the big change, when we simply get an answer that we can all understand. Well, that's all the big problems sorted out of chaos, turbulence, how the solar system has predictable parts and unpredictable parts. And we need to start using it straight away. There's no excuses anymore for not using this. So if you'd like copies of these charts, just get in touch with us. No problem. It's all free. This is information that's far too valuable not to give away. We can all understand it and use it. Bye for now.